Hello everyone, thank you very much for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Todd. Dr. Todd, you want a cookie? You drooling? Cookie for class? Very good. And welcome to PreAlgebra. We're going to start our Semester A final exam. This is part 1. I'm going to break this up into roughly 10 components over the next 2 weeks. This video, these live streams should be used as a diagnostic tool. We're going to go through brief multiple rounds of different questions, but it shouldn't be used or expected as it's an exhaustive review, and it's not as a replacement for your own individual teacher's review packet. There could be specific things that he or she leaves in or went over that other teachers in different school districts didn't. If you have any recommendations or if there's something that you don't find in my videos that you'd like me to go through, please leave a comment or contact me on my social media accounts. They're listed in the description below. But I want you to approach this video rather, as a resource. If you identify an area where you're a little bit uncomfortable, you should go into the extra resources that are listed in the description. There's going to be an independent practice problem set. That's going to be a rather long list of examples with the solution video that will go throughout different levels of difficulty. And then also the quick drill sets A and B. Those are going to be rather relatively shorter exercises, but at a higher level difficulty, and emphasizing word problems and real world scenarios wherever possible. So those are there for you, and you should use this. If anything in this video you find as difficult or confusing, you can go to those resources for extra practice. There's also going to be listed practice exams 1 through 3. Practice exam 1 is to allow you to use as a diagnostic tool, so you can identify areas of most needed improvement. And then practice exams 2 and 3 should be used right at the end before your exam to fine-tune your skills, just as an extra resource for different problems that you can use. If you have any questions, please let me know. Otherwise, let me share my screen with you. And just a reminder, it is a live stream, so there's a little bit of a delay with the iPad, but I'll try and mitigate that as much as possible. This document will be posted on Certified Learning Center's website. It isn't currently, but it will be shortly. Just make sure that you're looking at the document with the reference number 1849-4. That way you know that you're looking at the right one. Okay, so I'm going to give you 3 minutes to approach each one of these problems. About 1 minute in, I'll start to solve to give you some hints. And if there's any questions, then just let me know. But the first problem, we're going to look at evaluating expressions. So you have parts A and B. A asks 3x plus 2y minus z when x is equal to 5, y is equal to 4, and z is equal to 8. And B is asking you to simplify, or rather evaluate the expression 2 times the quantity 3x minus y, quantity plus 4z, when x is equal to 4, y is equal to 3, and z is equal to 2. So I'll give you 3 minutes. 1 minute in, I'll start to solve, and then we'll review in total. Okay, so for number one, wherever we see the the variable, I should say for number 1a, wherever we see the variable the variable x, we're going to substitute in the number 5 using parentheses. Wherever we see the variable wherever we see the variable y, we're going to substitute in the number 4, and wherever we see the variable z, we're going to substitute in the number 8. So we're going to have 3 times 5 plus 2 times 4 minus 8. 3 times 5 is 15. 2 times 4 is a positive 8. Notice how the positive 8 and the negative 8 are equal magnitudes but opposite signs. One is positive 8, the other is negative 8, and so they cancel out, leaving a final answer of just 15. For 1b, wherever we see x, we're going to put in 4. Wherever we see y, we're going to substitute in 3. And wherever we see z, we're going to substitute in 2. So that's going to leave us with 2 times the quantity of 3 times 4 minus 3, quantity plus 4 times 2. So 3 times 4 is 12. Working within the parentheses, 12 minus 3 is 9. So that leaves us with 2 times 9 plus 4 times 2 is 8. So we have 2 times 9 plus 8. 2 times 9 is 18. 18 plus 8 is 26. If you have any questions, then please let me know. Otherwise, let's look at question number 2. So 2 is asking us to evaluate the absolute values. (2a) is asking for the absolute value of negative 6 plus 3. And 2b is asking for the absolute value of negative 6 minus 3. I'll give you 3 minutes, and I'll start to solve after 1. Okay, so for number 2, remember what an absolute value represents. Practically, an absolute value turns everything positive, and it does have that effect. But the definition is a little bit more nuanced. It's actually the distance from 0 on a number line. So the effect of it, because -6, for example, is 6 units to the left of 0, the absolute value of -6 is +6. +6 is 6 units to the right of 0, so the absolute value of +6 is still +6. So here, you can remember it as it just turns everything positive, but technically it's the distance from 0 on a number line. So we need to evaluate within the absolute value before we can actually remove the bars and take the absolute value. Inside of the bars in 2a, we have -6 plus 3. When you're adding values that have opposite signs, the answer is going to take the sign of the larger value, or the value that has the higher magnitude. So here, -6 is farther away from 0 on a number line than +3. So when we add -6 to +3, the answer is going to retain the negativity because -6 has a larger magnitude. I was going to say higher magnitude, but I think it should be larger magnitude. So -6 plus 3 is going to be -3. The absolute value of -3 is +3 because -3 is 3 units to the left of 0. So if it's helpful, then you can think of it on a number line. If 0 is here, then -3, is going to be 3 units to the left. So the absolute value of -3 is +3. For 2b, again, we need to evaluate within the absolute value bars first. We have -6 minus 3. So there's a little handy trick here called leave, change, change. You're going to leave the sign of the first number alone, change the operation of the operator, or change the sign of the operator, change the sign of the second number. So it's leave, change, change. And what it does is it turns rather complex, seemingly complex subtraction problems into more straightforward subtraction or addition problems. So for example, -6 minus a +3 might be a little bit strange to wrap your mind around, but if you do leave, change, change, it'll show you that that's exactly equivalent to -6 plus a -3. -6 plus -3 is a lot easier to think about. That's obviously -9. So then that leaves us with the absolute value of -9, which is going to be +9, because -9 is 9 units to the left of 0 on a number line. So the answer to number 2 was 3, +3, and the answer to number 2a is +3. The answer to number 2b is +9. If you have any questions, please let me know. Otherwise, let's look at number 3. So number 3 is asking us to simplify the following expressions using the order of operations. Remember that the order of operations, you can remember them rather with the acronym Pemdas, parentheses, exponents, multiplication, division, addition, subtraction, working from left to right. 3a is asking you to simplify 3 times the quantity 2 times 5 minus 4, quantity plus 6. And 3b is asking you to simplify the quantity 16 minus 3 squared times 2, quantity squared. So I'll give you 3 minutes, and 1 minute in I'll start to solve. Okay, so the first letter in the acronym PEMDAS is parentheses, so we know that we have to work within parentheses if there are any first. In A, we have the parentheses including 2 times 5 minus 4. Now we have multiplication and then we have subtraction. Multiplication and division comes first, so we're going to multiply before we subtract. 2 times 5 is 10, and then we can subtract the 4 from the 10. 10 minus 4 is 6, so that whole parentheses, all the information or the data in the parentheses turns into just 6. 3 times 6 plus 6 is going to be the same thing as 18 plus 6. 18 plus 6 is 24. So the answer to, oh, I'm sorry, I wrote 2 here. This is question 3. My apologies. So the answer to 3A is going to be positive 24. For 3B, we have the quantity 16 minus 3 squared times 2 quantity squared. So again, working within the parentheses first, we have that outer exponent, but you have to do everything inside the parentheses before you touch the exponents. But we do have an exponent inside the parentheses, so that's the first item that we can tackle. 3 squared is the same thing as 3 times itself twice, or in other words, 3 times 3. 3 times 3 is 9. 16 minus, so we have 16 minus 9 times 2. But then, so now we have subtraction and multiplication. Multiplication division comes first. It doesn't matter whether the subtraction is to the left of the multiplication. 9 times 2 is 18. 16 minus 18 is negative 2. Negative 2 squared is the same thing as negative 2 times itself twice, or in other words, negative 2 times negative 2. Two negatives will turn into a positive when multiplied into each other. Negative 2 times negative 2 will give us a positive 4. So the answer to A was positive 24, and the answer to B was positive 4. So now we'll go back through as many times as we can before the end of class, some more examples of the same topic, subtopics. So those are the 3 subtopics for this video. Let's go ahead and look at question number 4, which is going to go back to evaluating expressions. 4A is asking you to simplify the quantity 4m minus 2 quantity times 3 quantity minus 5n when m is equal to 5 and n is equal to 3. 4B is asking you to evaluate the expression 9m minus 2m times the quantity 7 minus 4 plus the quantity 3 times the quantity 4n minus n when m is equal to 3 and n is equal to 2. I'll give you 3 minutes, and then after 1 minute I'll start to solve. Okay, so let's look at 4a and 4b. So if we substitute 5 in for m and 3 in for n in A, we're going to get 4 times 5 minus 2, quantity times 3, minus 5 times 3. Inside the parentheses, we need to do 4 times 5 first, so that's going to turn into 20 minus 2, quantity times 3, minus 5 times 3 is 15. 20 minus 2 is 18. So we're going to have 18 times 3 minus 15. 18 times 3 is 54. 54 minus 15 is going to be 39. So the answer to 4a is positive 39. 4b, substituting 3 in for m and 2 in for n, we're going to get 9 times 3 minus 2 times 3 times the quantity 7 minus 4 plus 3 times the quantity of 4 times 2 minus 2. So starting on the left, we have 9 times 3, that'll turn into 27. 2 times 3 turns into 6. 7 minus 4 turns into 3, so that combines to just 6 times 3 in the second line. I'm carrying down that scalar of 3 because I need to work within the parentheses all the way on the right first. I have 4 times 2 minus 2. 4 times 2 is 8, and then 8 minus 2 is 6. So this is going to simplify on the third line as 27 minus 18, coming from the negative 6 times 3, negative 18, plus a positive 18, coming from the positive 3 and positive 6. Notice that we have two values that have equal magnitude but opposite signs. So they're going to directly eliminate with each other. And so the answer to question 4b is positive 27, because the negative 18 and the positive 18 will cancel directly, leaving you with just positive 27 as your answer. If you have any questions, then please let me know. Otherwise, let's look at question number 5. Question number 5 is going to be involving evaluating absolute value signs. Question A, the absolute value of 4 minus 9 minus the absolute value of 2 minus 7. Question 5b, what is the absolute value of negative 8 plus 3, quantity minus 5? So I'll give you 3 minutes. 1 minute in, I'll start to answer. Okay, so for number 5, for 5a, we have the absolute value of 4 minus 9 minus the absolute value of 2 minus 7. So working within the individual absolute value bars first, 4 minus 9 is going to be a negative 5. 2 minus 7 is also a negative 5. So we're going to have the absolute value of negative 5 minus the absolute value of negative 5. The absolute value of negative 5 is positive 5, so this is going to turn into 5 minus 5, which is 0. For 5b, we have the absolute value of negative 8 plus 3, quantity minus 5. So take care of the absolute value first. We have negative 8 plus 3. That's going to leave us with a negative 5. So we're going to have the absolute value of negative 5. Let me go back here. So we have the absolute value of negative 5, because I believe I made a mistake. Absolute value of negative 5 minus 5. So that's actually, yeah, that's going to be 0 as well, because the absolute value of negative 5 is positive 5. 5 minus 5 is going to be 0. So my apologies, I flipped the sign there. So the answer to 5a is going to be 0. The answer to 5b is also 0 through different simplification pathways. Sorry about the confusion there. If you have any questions, then let me know. Otherwise, let's move on to number 6. And so we're using the order of operations again to simplify the following expressions. Question 6a asks the quantity 20 minus 4 squared, quantity squared, minus the quantity 14 minus 9, quantity squared. 6b asks you to simplify the expression the quantity 3 times 2 plus 10 times 3 minus the quantity 6 times 4 minus 5 times 3. I'll give you 3 minutes. 1 minute in, I'll start to solve. Okay, so for number 6, we're going to, first of all, working within the parentheses, there is an exponent in 6a, so we have a 4 squared. We can go ahead and evaluate 4 squared into the same thing as 4 times 4, which is 16. So that's going to turn into the quantity 20 minus 16 squared minus 14 minus 9 is 5, so minus 5 squared. 20 minus 16 is going to be 4. So we end up with, on the third line, 4 squared minus 5 squared. 4 squared is 16. 5 squared is 25. So 16 minus 25 is going to give us a negative 9. For 6b, working within the parentheses again, making sure that we do multiplication before we do addition or subtraction. 3 times 2 is 6. 10 times 3 is 30. So we're going to end up with 6 plus 30. On the left-hand side. On the right-hand side, we're going to have 6 times 4, which is 24, minus 5 times 3, which is 15. 24 minus 15 is 9. 6 plus 30 is 36. So we're going to end up with 36 minus 9, which is going to give us a positive 27. If you have any questions, then please let me know. I'm going to try and slip in this last one before the end of class, but let's go ahead and look at question number 7. 7a asks you to evaluate the expression 5 times the quantity 3a plus 2b minus 2 times the quantity 2a minus 3b when a is equal to 3 and b is equal to 4. 7b is asking you to evaluate the expression 6a minus 3b plus 3a plus 9b when a is equal to 5 and b is equal to 3. I'll give you 3 minutes. After 1 minute, I'll start to solve, and this will bring us up to the end of class today. Okay, so let's go through these last two problems here. So for 7a, we're going to substitute in 3 wherever we get a, wherever we see the variable a, and we're going to substitute 4 in for the variable b. So we're going to end up with 5 times 3 times 3 plus 2 times 4 minus the quantity 2 times the quantity 2 times 3 minus 3 times 4. Working within the parentheses first, 3 times 3 is 9, 2 times 4 is 8, so we're going to have 5 times 9 plus 8. On the right-hand side, again, working within the parentheses, 2 times 3 is 6, and negative 3 times 4 is negative 12. 9 plus 8 is going to be 17. 6 minus 12 is going to be a negative 6, so it's going to end up being 5 times 17 minus 2 times negative 6. 5 times 17 is 85. Negative 2 times negative 6 is going to be a positive 12. 85 plus 12 is 97. For 7b, we're going to substitute in 5 wherever we see a, and we're going to substitute in 3 wherever we see b. So we're going to get 6 times 5 minus 3 times 3 plus 3 times 5 plus 9 times 3. 3 times 5 is 30. Negative 3 times 3 is negative 9. 3 times 5 is 15. And 9 times 3 is 27. 30 minus 9 plus 15 plus 27 is going to give you a positive 63 as a final answer. So again, if you found any of these problems difficult, I would advise you to look at the independent practice problems and quick drill set A and B. And also, if you have any recommendations on any other videos that you'd like to see, please just drop me a line either on my social media or in the comment section below. I'm going to be doing these reviews all week, this week and next, every day for pre-algebra 5 o'clock to 5:45. If you find these videos helpful, then please like and subscribe, give me a thumbs up, and share with your friends. I appreciate all of you. And Dr. Todd, do you want to say goodbye to everybody? Come on, let's say goodbye. Up. Come on. You know what to do. Come on, do you want a cookie? Come on. Can you get a cookie? Come on. Can you say bye? Can you say bye? Come on, bye. But that's a little bye. Can you do a big bye? Say bye. Come on, bye. No, he doesn't want to say bye. He did a little bit. All right, thank you guys very much. Have a wonderful night, and I'll talk to you all tomorrow.